Hello and welcome to today's Quick Start, titled High Availability Storage for VMware vSphere. Hello, my name is Greg Shields, and in addition to being a Microsoft MVP as well as a VMware vExpert, I'm also a partner with Concentrated Technology at concentratedtech.com. I've been asked by StarWind Software to talk with you today a little bit about some of the different high availability storage options that are available for VMware vSphere. And because we're here on behalf of StarWind, we're going to talk a lot about the software-based solutions for VMware vSphere, specifically iSCSI SAN software. Now, iSCSI SAN software has actually been around for a long time, but you may be thinking to yourself, well, SAN software? When I think of a SAN, I think of these large refrigerator-sized devices that have lots of disks in them, or maybe even a small, but still, 2, 3, 4U device that I put a bunch of disks in and then I connect to. When I think of SANs, I think of hardware. Well, I want to spend some time today and talk with you about iSCSI SAN software because really you could argue that some of the features that are available in iSCSI SAN software really make them ready for production vSphere use. Let's talk a little bit about what really makes up a SAN. Let's deconstruct what a SAN is. What really goes into that giant refrigerator box that you may have in your data center today? What really makes up the storage area device that you're using? Well, in that storage area device, you've probably got a set of disks, right? Those disks are the storage that makes up the storage area network. You've probably got a bit of firmware or some piece of software actually that manages that SAN and actually handles connecting servers and users into that SAN. And speaking of connections, we also have to have some sort of connection medium as well. We have to have some sort of way of connecting those servers into that SAN. And that SAN's probably got a nice label on it as well, although the label sometimes is what ends up costing you the most. Well, if this is a SAN, well, what really makes a traditional SAN or a hardware SAN? If we're thinking again of those giant refrigerator boxes, what's inside that box? Well, that set of disks that we talked about, right? Those are disks that you buy from a SAN vendor. Those disks, now depending on what sort of vendor you're buying your SAN from, they may be specialized pieces of hardware that are designed by that SAN vendor. Or in a lot of cases, those disks are really just drives that vendor OEMs from somewhere else and repackages into a nice form that fit inside of the SAN. Now, that SAN also has that bit of firmware we talked about too, but the firmware is really nothing more than SAN software. Today, not a lot of SAN vendors make use of their own proprietary operating systems for actually driving the SAN. In most cases, SAN software is essentially a software application that runs atop a very tailored down instance or distribution of Linux or Windows storage server. And that connection medium is typically, in the case of iSCSI, is your common everyday NICs, or in the case of Fiber Channel, you have HBAs, and obviously you have that label like we talked about too. This is really what goes inside of that traditional SAN. Right, but if we think about these software-based SANs, how are these software-based SANs a little bit different than the traditional SANs? Right? If I think about a software application that I install to a server to actually turn that server into a storage network, well, what do I have then? Well, first of all, I have a set of disks. Right? Those disks may be the disks that are in the server. I may have some extra ones lying around that I plug into that server, or I may even buy some disks and install those into server hardware. Well, and then I have a bit of firmware as well, that's SAN software, which, well, it's an application that runs on top of Linux, or in many cases Windows Server, maybe not Windows Storage Server, but Windows Server. And we have that same connection medium. It's everyday NICs for iSCSI, it's HBAs for Fiber Channel. And a label, well, you can draw up your own label if you want and slap it on the front of that server. Really, the difference between a software SAN and a hardware SAN is that hardware SAN is a specific device. But it really has the same components in on the inside when you really think about it, right? Really, iSCSI SAN software is available today that you may be interested in using in your production environments, and specifically your VMware vSphere environments. This is an example of how that SAN may look. It's specifically a StarWind SAN. In this case, the StarWind software is actually installed to a server. That server then exposes some iSCSI-based LUNs to a number of ESX servers here in the middle. And those ESX servers have a number of virtual machines on the top that are running some sort of workload for our environment. Now, in this architecture, right, I have a number of ESX servers that are running a number of virtual workloads. And those ESX servers connect to that SAN. Now, this is a great solution for us, but wait a minute, there's something missing here. There's something definitely missing in this environment that really was what would make it useful for us in production. Let's think about this. So what's missing out of that picture? If we think about production virtualization today, right? Production virtualization puts a lot of heavy emphasis on high availability. Right? If I have 10 virtual machines that are running on top of a virtual host, on top of some ESX host or what have you, that ESX host is really, I put a lot of pressure on that ESX host. If that ESX host dies, those 10 workloads are all going to die at the same time. And so when I move to virtualization, I have to have these high availability features to ensure that I don't have this massive loss of all my resources. Right? I have them and they layer over the top of each other. I use things like vMotion to protect myself against host loss or planned downtime. I can use DRS, distributed resource scheduling, to protect myself against resource overuse. I can use NIC teaming to protect myself against network issues, or MPIO or fiber channel connection aggregation to protect myself against the storage network going down. If I have a wholesale disaster, I can even use site recovery and replication to protect myself against a disaster. But, well, wait a minute. All of those connections are all pointing into the same storage area network. For a long time, software-based iSCSI storage has had this limitation in the fact that all of these devices with all of their high availability features were connected into a single device, and that single device made a single point of failure for this entire infrastructure. Now, what's to say that with the way technology changes, that we couldn't take another one of those SANs and, well, connected to the first one, right? Let's think about this. If I had another SAN that I connected to the first SAN, just installing a piece of software onto an existing host somewhere and using existing disk in my environment, well, then I could connect those ESX servers to that secondary SAN as well. And as long as the data is synchronized between those two SANs, I could actually create a highly available storage environment for my highly available virtualization environment. Wow, this is very interesting. Let's think about this. If I had that high availability for those software SANs, I could do a number of very interesting things. First of all, I could have this concept of synchronous data mirroring between those two devices. So I have two devices, and the data between those two devices is automatically and transparently mirrored between those configured servers. I install a piece of software like StarWind onto one host and install it onto another, and I point the two of them together, and then they go about their merry way, actually mirroring the data backwards and forward. Now, the interesting thing about this is that when I do this, then I have this sense of high availability with seamless failover, right? I have my ESX servers that are connecting into these two StarWind software-based SANs, and if one of those hosts goes down, maybe it goes down because I had to update it and install some patches. Maybe it went down because a problem occurred. Maybe I just need to reboot once in a while. But when that server goes down, the loss of that server does not impact my running virtual machines. I have a single presented endpoint to my ESX environment, so really there's not much of a change in my configuration with the ESX. A little bit later, I'm going to show you a little demonstration about how this works. And then also, when that host that failed comes back, I then can have the ability to resynchronize the data that it missed over to the failed host when it comes back to operations. So then, once I bring that server back online, I say, you know what, go back and fail back and resynchronize all your data and make yourself a fully synchronous site again. Now, this is some pretty interesting stuff with these software SANs. There's some more tools that we can have once we create this capability as well. One is this concept of remote asynchronous replication. Right? If I want to do synchronous replication, I kind of have to have these two servers relatively close to each other in the network. But I could also very easily replicate that data asynchronously to another location. Perhaps it's a backup location. Perhaps it's an offsite location for disaster recovery. Aha! I could snapshot that data, just like in a hardware SAN. I could snapshot that data to provide instantaneous point-in-time images for testing or demonstration or for just verification, protecting myself against an update going wrong. And I have this concept of continuous data protection. If something happens, if I get data corruption on that SAN, I can create more or less operationally unlimited rollback to any point in time that I've configured to revert that volume to a previous state. Now, this is actually pretty cool. This protects me against those corruption events. Now, one of the interesting things, or a couple of interesting things about this iSCSI SAN software is that when you use iSCSI, and when you use software-based SANs, your iSCSI runs over your existing Ethernet network. And this is, at least for me, this is a pretty interesting thing, a useful thing, because this networking infrastructure already exists in your IT environment today. You already have an Ethernet network because that's what your entire infrastructure is running off of. So in order to use iSCSI in that network, you really don't have to have much of a major infrastructure or hardware upgrade to implement storage, right? And most importantly, you are already familiar and experienced with IP networks and networking. You already understand the best practices and the conventional wisdom associated with IP networks and networking. Understanding some of those other connections like fiber channel involves more education and more understanding and more making mistakes until you realize how to do it correctly. iSCSI SAN software can be installed to really any x86 server with the 64-bit Windows, 32-bit Windows. I'm talking specifically here about StarWind software. But this software essentially installs over the top of an existing server and using your existing hardware, your existing disks, and your existing OS instances. And high-speed caching of those software solutions atop high rotation speed drives can ensure a very high level of performance. So you're going to get the kinds of performance that you need out of your VMware vSphere environment. And what's most important too is that unlike fiber channel connections that need to get pulled into different locations into your environment, iSCSI connections are on that same production network. They may be on a different VLAN, but they can be easily routed to where you need them, making iSCSI connections very pervasive for not only their connecting into your ESX hosts, but also your virtual machines and your physical machines and other places throughout the network. Here's another look at that software SAN and how that software SAN might look. Here in the middle we have a couple of different ESX hosts that are using a couple of Ethernet switches to connect to a couple of StarWind servers back in the back end. And those StarWind servers host the storage for that ESX environment and its virtual machines. Now you're here today to really take a look at some of those high availability storage capabilities. And really, how do you go about configuring high availability storage for VMware? Let's take a couple of minutes and go through a quick demonstration of some of the high availability storage options for VMware that we would use using software SANs. So let's actually minimize this, and I'm going to take you to a little environment that I've built. Here you'll see I've got the VMware vSphere client, and the vSphere client is connected up to two different hosts, 0.221 and 0.222. And our old friend, the Nostalgia game, is actually running on this cluster that we've created here. In fact, here's the block out video game that comes with the Nostalgia download. And you'll see here that the blocks are actually doing their thing, and I can move them around and drop them down if I want. This is here to prove that I can actually show you a functioning virtual machine that's running on top of VMware vSphere. Okay? Let's actually make this go away here, and I'm going to show you how this Nostalgia game is being stored inside of this ESX environment. Let me click over here. I want to take a look at this host. I'm going to look at its configuration here, and you'll see I've got my storage adapters node up here. And under the iSCSI software adapter here, this VMHBA number 33, you'll see that I actually have a software adapter connected in here, and I'm pointing this initiator to a target. This target is here. This Rocket iSCSI disk here. This is a disk that's been created. It's about 3 gigs in size. It's not very large. And this target here is actually being connected to by this adapter. It's also being connected to by the other adapter as well. If I take a look at storage here, you'll see that I've created a data store for it. I'm going to view the properties of this data store here for a second to show you that in this data store, we currently have a single device that is formatted as VMFS. And if I take a look at the list of paths for this device, you'll see that I have 2 active paths for the connection to my iSCSI storage. Now, in the hardware iSCSI SAN world, these 2 paths would probably be 2 different connections to 2 different storage processors on my SAN hardware. Right? And if I lost a storage processor, then I'd know I would have another path that I'd maybe connect through different networking equipment so that I would always have the ability for my virtual machines to talk to their storage. What's interesting is I can do the same thing here with solutions like StarWind. Let me show you the StarWind Management Console here. Now, what's interestingly different about how this connection occurs between my ESX hosts and my StarWind iSCSI targets is that those 2 targets are actually installed onto 2 different servers. You'll see here I have vc.contoso.com. This is 192.168.0.220. And I have another server here at 192.168.0.55. I am created a LUN here, more or less, called VM1. And I have a VM1 partner LUN over here as well. This is actually, this iSCSI area of storage is being replicated between these two devices, between these two hosts, and we currently have synchronization that is occurring. You'll see here that I have synchronization status is set to synchronized, and the progress is set to 100%. These two hosts are functionally synchronizing the data back and forth between them so that in the case of one of those gets lost, then I can still maintain my virtual machines. Let's actually prove this, right? I showed that these are on two different hosts right here, and we've taken a look at this nostalgia video game here. But let's actually see or experience what would happen if we were to experience a failure in one of those two hosts. As I said before, that failure could be I needed to reboot the computer. That failure could be I lost power to the computer. That failure could even be I lost the service or the process that runs StarWind. Let me bring up the services node here, and you'll see here that the StarWind iSCSI service actually has a process here, and it's started. And I could stop the process here, but that's a little too graceful. Let's get a little crazy here, and instead of actually stopping the process, let's actually stop the correct service for it, the StarWind service.exe. Let me go ahead and just kill that process. This is about the least graceful way that someone could go about killing a particular process or service. Here's the StarWind service.exe. I'm going to end that process right here. Bam, it's ended. And I take a look again at my little nostalgia video game, and it looks, well, I can still go about and see the changes that are going on with that nostalgia video game. It's still moving the pieces as they click up and down. So even though I've lost one of the paths to my connection, to my iSCSI target, I still have the ability for those virtual machines to continue operating with no problems. You'll see here now this virtual machine, or this machine has actually lost connection because we've lost the StarWind service. If I go back in here to my VC and take a look, you'll see that the path here is now marked as dead. I've functionally lost that path in its entirety. Now I can continue by actually going back to services here and actually restarting the service if I want. But what this does is it proves to you that even through a very ungraceful process of killing the service that belongs to StarWind, I can very easily go back and maintain the paths from my servers to my storage. What I effectively have at this point is true high availability for my VMware vSphere environment. Now you'll see if I click the refresh button here that this path is returned to active once again, and my nostalgia video game, well, my nostalgia video game is still working there in the background and doing what it needs to do. Now there are two pieces left of this demonstration that I really need to go through so you can fully understand all the steps that are involved with working with a solution like this. Now the first of which is I actually need to go back to my StarWind console after I've replaced the failed service, or I brought the server back up, and I need to go back and actually resynchronize the data. I do that by logging back into that lost server here and with the username and password. And once I've logged into that server, then I need to go to the server that was down and right-click the image there, the actual exposed LUN, and tell it to do a full synchronization. What this is going to do is complete the synchronization back, returning any of the changes that have occurred while that machine was down. Once those changes have been returned and both of those two hosts are resynchronized again, both of these hosts will return to full capabilities, and you'll have that full sense of synchronization between the two hosts. You'll see now that we are complete, and we now have two happy hosts with two happy LUNs between the two hosts. The second thing I need to show you is actually how you would go about creating another LUN. So if you wanted to go and create a new data store for your ESX environment, you would obviously need to start the process by creating and carving out that little bit of disk space and then exposing it via iSCSI. Okay, the way that we go about doing that actually is let's click down here and choose targets, and we actually want to create a new target. Okay, we'll give this target a target alias of VM2. And choose the next button, and we're going to create it as a type hard disk because we want to create a hard disk. And in this case, here inside of the StarWind interface, we want to create it as an advanced virtual device type because this is what allows me to use the advanced functionalities such as high availability. If I click the next button here, I'm going to choose a high availability device. There are a number of different devices I can choose, but in this case I want to show UHA. And then next again. Now in this case, I need to, or in this wizard screen, I need to show you which host will be the partner host for the one that I've already created the LUN on. Now I've created the LUN over here on this host called Big Hit 0.55. The partner server will be 192.168.0.220. Okay, and then I need to use the username, which is root, and the password, which is StarWind in all lowercase. That's the initial password when you first install the software. And choose the next button here, and it will actually connect to that host and create a partner target, which is the name of the other target, but with the word partner added behind it, and the next button again. And then I need to create locations for where I actually want to store those virtual disks on the local and the remote device. In this case, I'm just going to put them on the C drive here. You'll see here's VM1 partner. I'm going to create this one called VM2.img. And then over here, I'm going to create another one called VM2 partner.img. Okay, there we go. I'm going to create new hosts here, and I'm going to give it a size of, let's call this one 2 gigabytes. Okay, so what I'm doing is I'm creating the image file that is effectively the piece of space that is being carved out by this iSCSI target and will eventually be exposed to the initiator on the other side. If I click the next button here, it will go ahead and create those. I need to choose the interface at which it will actually be exposed through. In this case, it's 0.55 and 0.220. The host Big Hit is the primary server. The host 0.220 is the secondary server here. I choose the next button again. I want to clear the virtual disks. What this allows me to do is either clear those disks, do some various synchronization tasks, or even don't synchronize those virtual disks if I want. And choose the next button again, and it will actually go through creating that target. I'm going to choose the Finish button here, and it will begin clearing the nodes. Now, one of the things that you'll find out when it goes through this process is if I refresh the second node over here, you'll see that I've got this little warning box to let me know that I haven't actually completed the synchronization just yet. That synchronization takes a little bit of time. You'll see over here that we're synchronized down to 7%. And as I watch, this synchronization process will occur over a period of time and complete once it's gone through all the synchronization between the two hosts. You'll see down here it's down to 13%. Now, I'm not going to wait for that synchronization to complete. I can actually go back to my VC environment, my virtual center environment. And if I close this down and close this down, I can actually go back to my storage adapters location and rescan for the available new storage devices that have been exposed to this initiator. And you'll see that after a short delay, the other disk appears down here. And if I scroll to the right, you'll see that this is the 2 gigabyte disk as opposed to the 3 gigabyte disk. The last thing I need to do is actually go through and take this disk and format it VMFS and make it available as a data store. And I would do that here under Add Storage, create a new disk LUN, assign this 2 gigabyte disk actually as we created, hit the next button here, and go through the process of actually creating this disk as a new data store. Here's data store _2, and then give it the correct block size information, maximize capacity, all that stuff. Once I'm complete, I now have an additional data store that I can use, and like before, this second data store is highly available just like the first data store is because it's running on top of that high availability features of the StarWind iSCSI software. So really, what have we talked about here over the last period of time? We've talked about high availability, and specifically we've talked about high availability within the constructs of VMware and high availability storage for VMware vSphere. And hopefully now you've had an opportunity to see some of these iSCSI SAN software solutions that are out there, and also some of the features that they have, the high availability features, the capability for synchronization, all of that. And at this point, I'm going to turn the discussion over to the other speaker who's going to continue on with a little bit more specific information about StarWind software.